Today's challenge goes something like this. Given an array of integers and a number k, the number of subarrays is counted where the maximum element appears at least k times. A subarray is a continuous sequence of elements within the array. Brute force would be too slow, as it would involve checking every possible subarray, which could be a massive undertaking for large arrays. A more clever approach is needed. Let's employ a sliding window technique, combined with a hashmap to keep track of the frequency of each element within the current window. First, let's initialize 2 pointers, left and right, to define the boundaries of the sliding window. Let's also create a hashmap to store the frequency of each element in the current window, as well as a variable to keep track of the maximum frequency seen so far. With our trusty tools in hand, our journey begins through the array. Move the right pointer one step at a time, updating the frequency of the current element in the hashmap. If the frequency of any element exceeds the current maximum frequency, the maximum frequency can be updated accordingly. But that is just the beginning. The real challenge lays in determining when a subarray satisfies the condition of having the maximum element appear at least k times. Whenever the maximum frequency becomes greater than or equal to k, a valid subarray has been found. But how many valid subarrays were there within the current window? To find out, let's employ a clever trick. Keep sliding the left pointer to the right, removing elements from the left side of the window and updating their frequencies in the hashmap. As long as the maximum frequency remains greater than or equal to k, all subarrays within the current window are valid, and the size of the window can be added to the count. With each step of the left pointer, the changes in the hashmap are carefully tracked, adjusting the maximum frequency as needed. If the maximum frequency ever drops below k, the end of the valid subarrays for the current window has been reached, and we could move the right pointer forward to explore new possibilities. Through this ingenious approach, we are able to efficiently count the number of subarrays where the maximum element appeared at least k times, without having to check every single subarray individually. And so, with a clever solution in hand, we emerge victorious, having conquered yet another challenge in the vast realm of programming. Rustin has triumphed once again.